Assalamu alaikum, welcome to a new video. Today we're going to talk about blood groups. Many years ago, when people used to get wounded in wars or different accidents and they started bleeding and losing blood, they used to give them or receive blood from any source, from different people and even sometimes from animals. And although people thought that this procedure will save the lives of these people and will help them compensate the lost blood, most of these patients or wounded started dying. The question was, why? Why did these people die even though they received the lost blood? Nowadays, blood transfusion is much more complicated process. It has to pass through several tests in order to make sure that this blood is what we call compatible for this patient in need of blood. Now, before we go in details about blood groups and blood, we have to recall what we learned earlier about the immune system and how it differentiates between self and non-self using a special complex, a special molecule called MHC, where this MHC is a protein complex found on the surface of nucleated cells. And we learned that this MHC, or what we call markers of cell, is found on all the cells, all the nucleated cells of the body. Okay, this is MHC. This MHC has the role of differentiating self from non-self. So if something has the same marker, it can enter the body, but if something has different markers, it cannot enter the body. The body fights it. This is how MHC works. But what about red blood cells? The red blood cells, since they are anucleated cells, which means that they do not have a nucleus, they have, of course, a special system. We can't leave the blood unguarded. We can't keep the blood susceptible to foreign things that can harm the blood or harm the body. That's why there is a special system related to the blood, red blood cells, which is called the ABO system. Now, what is this system all about? This system was discovered by Karl Landsteiner in 1901. There are special antigens found on the surface of red blood cells called agglutinogens. So also in this system, there are special antigens. Antigen is a protein found on the red blood cells, on the surface of red blood cells. But these antigens are not MHC. They are called agglutinogens. They have a special name, which is agglutinogen. There are two types of agglutinogens, agglutinogen A and agglutinogen B. Okay, now let's go deep into the idea and discover what about these agglutinogens, these antigens, A and B, how do they affect the blood group? So this is the red blood cell. Let's say this is the red blood cell, which is a disc-shaped cell, anucleated, okay? And on the red blood cell, we have a special chain called CHO chain or carbohydrate chain. So on the surface of red blood cells, we have certain chains called carbohydrate chains, okay? Now, sometimes these chains have a molecule here connected to it, okay? And in this case, when this molecule is connected to it, we have antigen A. And in some other cases, another type of molecule is connected to this chain, and which makes it antigen B. So the agglutinogen is made of carbohydrate chain found on the red blood cell. Attached to it a special molecule. One molecule makes this an antigen called A, and if another molecule is connected to the chain, it makes antigen B. So the base is the same. The only difference is a small molecule at the end. These details are not very important. You have just to understand that we have different antigens or agglutinogen A and agglutinogen B, and they can be found on the surface of red blood cells. Now, in case there is agglutinogen A on the surface of blood cell, like this case here. So that we took blood from a person, and this person has on the surface of his red blood cells has agglutinogen A. In this case, this person, we say that his blood group is A. So if there is antigen A or agglutinogen A on the red blood cells, the person is of blood type A. While if another person has on the surface of his red blood cells antigen B, what do you think? Of course, his blood type or blood group will be blood type B. Now, if a person has both these antigens, agglutinogen A and agglutinogen B, or antigen A and antigen B, what do you think the blood type would be? Of course, it is AB. He has both A and B, so his blood type is AB. And finally, sometimes the red blood cell has neither antigen A nor antigen B. It has the carbohydrate chain without any molecule attached to it. So the carbohydrate chain is already there, but it doesn't have this special molecule connected to it. So it doesn't have antigen A or antigen B. No antigen, no agglutinogen. In this case, the blood type would be, what do you think? Yes, it is blood type O. And here we have a funny information maybe, that blood type O was first called blood type 0. 0 refers to no antigen, 0 antigens on the red blood cell. But because the 0 looks like O, they later on called it blood type O. So we conclude from what we said that the definer of the blood type, or the thing that defines the blood type or decides the blood type, are the antigens or the agglutinogens on the surface of the red blood cells. These agglutinogens are the deciders of the blood type. Now it's time to dig deeper in the information and the concept of blood types and blood groups. Let's take the first case. If a person has blood type A, a person having blood type A, let's say this is the blood capillary or the blood stream of this person. This person will have red blood cells holding antigen A on their surface. Now, in the serum of this person, the serum means the plasma. You know that the blood is made of red blood cells, white blood cells, and platelets, and all of these are found in a liquid, which is the plasma, or also called the serum, another word for plasma of the blood. In his serum, this person will have a lot of antibodies. Naturally, the antibodies that are responsible for fighting foreign bodies, fighting non-self, these antibodies are present in the serum, and each antibody is responsible or specific to fight a special type of non-self. Now, let's imagine that this antigen found in the red blood cell, okay, antigen A, as any antigen, it has to have an antibody specific for it. In your opinion, if a person of blood type A having agglutinogen A on his red blood cells, would he have anti-A or anti-B antibodies in his serum? What do you think? Do you think it's possible for a person of blood type A having antigen A on his red blood cells to have anti-A? What do you think will happen if this person has anti-A antibodies in his serum? What will happen is something we call agglutination. We see here in the figure how the antibodies bind to the antigen, as they do. Any antibody, its job is to bind to the antigen and neutralize it and make it heavy and make it dense and can't move through the blood. This event happening is called agglutination. And this agglutination, if it happens in the body or in the bloodstream, it is a very dangerous thing. It shouldn't happen, because let's imagine if this happens in the bloodstream and you have clusters of blood like this, red blood cells together, what will happen? The bloodstream will be blocked. The vessel, the capillary, anything, it will be blocked. There will be blood clots all around the body. So the blood will stop moving. This is a very dangerous thing to happen. So after talking about agglutination, what do you think? Can a person of blood type A having antigen A on his red blood cells have anti-A antibodies in his serum? Of course not. He shouldn't. So a person of blood type A having antigen A on his red blood cells should not have anti-A antibodies. he will have anti-B antibodies. And having anti-B antibodies is not dangerous because look at the shape of the antibody, the binding site of the antibody. It can't bind to the antigen, so it doesn't harm, it doesn't lead to agglutination. Now, we have to follow the same steps. If a person of blood type B, what will he have in his blood? Of course, he will have antigen B on his red blood cells. What about his serum? Can he have anti-B antibodies or anti-A antibodies? What do you think? If we follow the same method of thinking, of course, he will not have anti-B antibodies, he will have anti-A antibodies, because if he have anti-A, anti-B, the anti-B antibodies will bind to the antigen B and will lead to agglutination, which is very dangerous, as we said. And now, a person of blood type AB, what will he have in his bloodstream? He will have red blood cells containing both antigens A and B at the same time. This person in his serum, can he have anti-A or anti-B antibodies? Think very carefully. Will he have anti-A or anti-B antibodies in his serum? Of course, he shouldn't have any. He shouldn't have anti-A or anti-B in his serum. Why? Because if he have anti-A, the anti-A antibodies will bind to the antigen A and will make agglutination, and the anti-B antibodies will bind to the, or if he has anti-B antibodies, even if he doesn't have them both at the same time, even if he has only, for example, anti-B, the anti-B will bind to the antigen B on the red blood cells and will lead to agglutination. So this person of blood type AB should not have any antibody, neither anti-A nor anti-B, or it will lead to agglutination. And finally, with the last blood type, which is O, in his bloodstream, the person of blood type A, we said earlier that he will have no antigens on his red blood cells, neither antigen A nor antigen B. And in this case, which serum is he allowed to have? Anti-A or anti-B? Of course, he can have both. He can have both. He will have both because he doesn't have any antigen on the red blood cells. So there will be no agglutination. He has anti-A and anti-B antibodies in his serum. Now, if we want to sum up all what we talked about, we have this table here and the four main blood groups, AB, AB and O, the red blood cell type or the antigens. Okay, we have A, B, AB and O. The antibodies in the plasma. In case of blood group A, there is anti-B. In case of blood group B, there is anti-A. In case of blood group AB, there are no antibodies whatsoever in the plasma. And finally, in blood group O, we have both anti-A and anti-B antibodies. And the antigens, of course, in each case are shown in this table. This table is very important for you to study. That's it for now. Thanks for watching the video. Make sure to stay tuned for the second part of this lesson, which is very important, to learn about how can we know the blood group, how can we test for the blood group of a person and know which type is it. Goodbye.